Let's work a couple of simple problems involving gears. Here we have two gears, each on fixed pivots, one with radius R1, the other with radius R2. Notice the choice of convention for positive omega 1 and positive omega 2. The problem is very simple. Given these two radii, find the ratio of the speeds, the so-called gear ratio. Recognize that the gears are in a non-slip condition. The gear teeth preclude or prevent the gears from rotating relative to one another. And the definition of non-slip is that the velocity of one side of the interface is equal to the velocity of the other side of the point of contact. Second, recognize the point of contact in between the two gears and calculate that velocity. In terms of R1, clearly this velocity is omega 1 times R1, and that same velocity is equal to omega 2 R2, a little bit of algebra, and you have the result. Omega 2 over omega 1 is equal to R1 over R2. Important to keep in mind that sometimes gear pairs are organized such that one is inside the other, not unlike the planetary gear problem on your homework. The situation, however, is the same, both on fixed pivots, one with radius R1, the other with radius R2. Note the directions of positive omega 1 and omega 2 respectively. The question is the same. Given the radii, find the ratio of the speeds, also the gear ratio. As before, the key to solving the problem, recognizing that their gears do not slip relative to one another. Identify the point of contact, which has a common velocity. You write the expression for the velocity in terms of each gear. Omega 1 R1 has got to be equal to omega 2 R2. And as before, the ratio of omega 2 to omega 1 is given by R1 over R2.